Hello, welcome to section 10.1 sequence and summation notation. In this lesson, we are going to see how to use a recursion formula or how to find the particular terms given that general term, and also we will see how to find the sum of n sequence using summation notation, and also we'll see how to use a factorial notation. Please, in each example, after each example, practice a checkpoint from your textbook. So directly I will proceed to example one. In example one, we are going to see how to find the end terms of a sequence, okay? The end term of a sequence, given that the general term is given. But before that, I just want to say something about a sequence, okay? I don't think that you are new for this term, sequence. You are familiar with it. But anyway, I just want to refresh your mind with the term sequence. Okay, definition of a sequence. An infinite sequence, A sub n, is a function whose domain is a set of positive integers. Okay, the domain of an infinite sequence is positive integers, and the function values or terms of the sequence are represented by a sub 1, a sub 2, a sub 3, a sub 4, and so forth. So in infinite sequence, you don't have the final terms, okay? Each uh, each terms, as you can see, they are represented by an index of a positive integer, okay? A sub 1, A sub 2, A sub 3. So A sub 1 is the first term, this is the second term, and so forth. So in infinite sequence, one thing that you should know, there is no final term. And if there is a final term, then the sequence is said to be a finite sequences. So a sequence whose domains consist of only of the first n terms of positive integer, which means that you have a final term, which we call the sequence a finite sequences. So let's go to example one. So in example one, what we are going to see, we are going to see finding the terms from the general term. So the general term is given, and you are asked to find the nth term of the sequence. So we are going to practice example one. Okay, in example one, you are asked to write the first four terms of the general term, which is given by a sub n is equal to 3n plus 1. This is very simple. What you need to do that, you just start with n is equal to 1 just to find the first term. As we know that for any sequence, the domain are positive integers, therefore I need to begin with n is equal to 1. So a1, which is the first term, it will be 3 times 1 plus 4. So this will be 3 times 1 is 3, 3 plus 4 is 7. So this is the first term. This is the first term. To find the second term again, I need to plug n is equal to 2 to find the second term. So it will be a sub 2 is equal to 3 times 2 plus 4 plus 4. This will be 3 times 2 is 6, 6 plus 4 is 10. This is the second term of a sequence given by 3n plus 4. To find the fourth term, just plug n is equal to 4. So this will be a, we have to find the third term. I just jump it to the fourth term. So, and to find the third term, n is equal to 3, so which is a sub 3 will equal to 3 times this time n is 3 plus 4 plus 4. 3 times 3 is 9, 9 plus 4 is 13, so this is the third term. And again, to find the fourth term, so what I need to do, I will plug 4 in n. So it will be a sub 4, which is the fourth term, is equal to 3 times 4, 4 plus 4 plus 4. So 3 times 4 is 12, 12 plus 4 is 16. So these are the first four terms of a sequence 3n plus 4. Okay, so this example 1 part A. Let's go to B, which is a sub n is equal to negative 1 the power of n over 3 the power of n minus 1. So to find the first four terms, what we need to do, we need to just plug the values of n's. So again, I will begin with n is equal to 1. So this will give me the first term. So a sub 1 will be negative 1 the power of 1 over 3 the power of 1 minus 1. So this will be negative 1 the power of 1 will be negative 1 over 3 the power of 1 is 3, 3 minus 1 will be 2. So this is the first term of the sequence. To find the second term, I'll just plug 2 in n. So this will give me the second term. So the second term will be a sub 2 is equal to a sub 2, which is the second term, okay, equal to negative 1, the power of negative 1, the power of 2, power of 2 over 3 the power of 2 minus 1. So negative 1 the power of 2, it will be 1 over 3 squared is 9, 9 minus 1 is 8. So this is the second term. So by the same method, you will find for the third term, you just plug a sub 3, which will give you the third term is equal to negative 1 the power of 3 over 3 cubed minus 1, this is 3, okay, 3 cubed minus 1, which is going to be negative 1 over 3 cubed 27, 27 minus 1 is 26. Okay, then the fourth term, again, it will be n is equal to 4. So this will give me the fourth term, a sub 4. This will be negative 1 the power of 4. This is 1 the power of 4 over 3 raised to 4 minus 1. So this will be 4, sorry, negative 1 the power of 4 is 1 over 3 the power of 4 is 81, 81 minus 1 is 80. So these are the four terms of the sequence. So this is example 1. Then please go to your textbook and practice checkpoint 1. Okay, then I will directly move to example 2. Okay, in example 2, we are going to use a recursive formula. So in a recursive formula, one thing that you should know that to find the nth terms of a sequence, you need to know the previous term. Okay, a recursive formula, it defines the nth terms of the sequence as a function of the previous term. So we will see example 2. In example 2, we will see how we can use a recursive formula. Okay, so let's go to example 2. So in example 2, what you are asked to find the first four terms of a sequence given by the expression a sub 1 a sub n is equal to 3 times a sub n minus 1 plus 2, where n is greater than or equal to 2. So as you can see here, the first term is given. Okay, the first term is given. That means the coming terms are depend on the previous terms. For example, the second term depend on the first term. So let's find the second term. So to find the second term, first I need to plug the value of what? The value of 2. Okay, the value of n is equal to 1 is given here. So n is equal to 2 will be just like 2 in n. So this will be a sub 2 is equal to 3 times a sub 2 minus 1, 2 minus 1 plus 2 plus 2. So this will be a sub 2 is equal to 3 times 2 minus 1 is 1, so I will get 3 times a sub 1 plus 2 plus 2. So this will be equal to 3 times a sub 1 means the first term, which is given by 5 plus 2 plus 2. So I'll get 3 times 5 is 15, 15 plus 2 is 17. So the second term of the sequence is 17. And to find the third term, what I need to do, I need to plug n is equal to 3 in the recursive formula. So a sub 3 is equal to 3 times a3 minus 1 plus minus 1 here, there is 1 here, plus 2 plus 2. So this will be 3 times a sub 2, which is the second term, plus 2 plus 2. Then I will get 3 times the second term is 17 plus 2. This is 17, okay, plus 2. 3 times 17 is 51. 51 plus 2 is 53. Okay, this is the third term of the sequence. Then finally, let's find the fourth term. So to find the fourth term, I need to plug n is equal to 4. So n is 4. So is equal to 3 times, it will be what? The third term plus 2 plus 2. So this will be 3 times 53 plus 2. Okay, 3 times 53 is 159. 159 plus 2 will be 161. 161. So these are the first four terms of the sequence given by an is equal to 3 times an minus 1 plus 2 for n greater than or equal to 2. So this is example 2. Sorry, this is example 2, not example 1. I didn't write this one. So this is example 2. Please go to your textbook and practice checkpoint 2 after you watch this video. Okay, so you need to practice checkpoint 2 from the textbook. Then I will go to example 3. Okay, example 3, it deal about factorial notations. Okay, so in example 3, you are asked to find the nth term of a sequence involving a factorial notation. If n is a positive integer, the n factorial is the product of all positive integers from n down through 1. So this is the factorial notation for n, and factorial is equal to the product of the positive integers starting from 1 to 1. Okay, starting from n to 1. One thing that you need to know is that 0 factorial is equal to 1. This is a very important point. So let's go to example 3. Example 3, which involves with factorial notation. Okay, example 3. So in example 3, what you are asked to find, you are asked to find, the first four terms of a sequence given by a sub n is equal to the power of n over n minus 1 factorial. Okay, so what we need to do, again, we need to do by plugging the values of n in the general formula, which is given by an is equal to the power of n over n minus 1 factorial. So let's find the first term. So to find the first term, I need to plug n is equal to 1 in n. So a sub 1 will be the first term, which will be to the power of 1 over 1 minus 1 factorial. So this will be equal to the power of 1 will be 2. So 2 over 1 minus 1 is 0 factorial. And as we said earlier, 0 factorial equal to 1. So this will be 1. So our first term will be 2. To find the second term, n is equal to 2. And I will plug 2 in n. So I will get the second term. This will be equal to the power of 2. To the power of 2. This is 2 over 2 minus 1 factorial. 2 minus 1 factorial. This will be to the power of 2 will be 4. 4 over 2 minus 1 is 1 factorial. 1 factorial is equal to 1. So this will be 4 over 1, which is equal to 4. This is the second term. Again, to find the third term, I will plug n is equal to 3 in the general formula. So it will be a sub 3 is equal to the power of 3, which is equal to 8. This is 3. Okay, sorry. This is 3. So to the power of 3 over 3 minus 1 factorial. 3 minus 1 factorial. So this is equal to the power of 3 is 8 over 3 minus 1 is 2. So this will be 2 factorial. 2 factorial means 8 over 2 factorial means 2 times 1. Okay, 2 times 1, which is 2. And 8 over 2 will be 4. So the third term will be 4. And finally, let's find the fourth term. So to find the fourth term, I just plug n is equal to 4. So like 4 in n. So you'll get to the power of 4, which is 16, to the power of 4 over 4 minus 1 factorial. 4 minus 1 factorial, which is 3 factorial. So this is equal to 16 over 3 factorial. And as we know, 3 factorial is equal to 3 times. That means you just start from 3 and goes to 1. So the product of 3 times 2, 2 times 1, okay, which is going to be 6. Okay, 16 over 6. and simplify this one, you'll get 8 over 3. 8 over 3. So this is our fourth term. Okay, so please go to your textbook after you finish example 3. So practice checkpoint 3. Okay, checkpoint 3. Then we'll go to example 4, which is going to be about sigma notation or summation notation of a sequence. Example 4, it talks about the summation notation. The sum of the first n term of a sequence is represented by the summation notation or sigma notation. Okay, here I is the index of the summation, and 1 is the lower limit of the summation, and n is the upper limit of the summation. And another thing here, we can use the index of the summation, any letter. Okay, we can use any letter. For this particular example, for example, we use I is equal to 1, which is the index is 1. So let's go to example 3. Okay, sorry, example 4. So in example 4, you are asked to expand and evaluate the given expression. So the general term is given, I squared plus 1, where I ran from 1 to 6. So here, what we need to do is that we need to expand first, okay? That means we need to plug all the positive integers starting from 1 to 6 into the expression I squared plus 1. So let's plug each values of I. So here it will be, the first term will be 1, which is I is equal to 1. So 1 squared plus 1, okay, plus, to find the next one, I need to plug 2 in I, 2 squared plus 1, plus 1, this is 2, plus, you need to plug 3, so it will be 3 squared plus 1, plus, I have to go up to 6, 4 squared plus 1, plus, the next one will be 5 squared plus 1, 5 squared plus 1, plus, and lastly 6 squared plus 1. Then I need to find the sum of all this. So 1 squared is 1, 1 plus 1 will be 2, this will be 2, 2 plus 2 squared is 4, 4 plus 1 it will be 5, plus 3 squared will be 9, 9 plus 1 will be 10, plus, sorry, I need to put this one. So this will be plus, okay, 4 squared is 16, 16 plus 1 will be 17, 17 plus 5 squared is 25, 25 plus 1 will be 26, 26, 26 plus 6 squared plus 1, which is 36 plus 1, it will be 37. So the sum of all this is going to be equal to, so the sum of all this is going to be equal to 97. So this will be 97. Okay, 97. Let's go to the second one. Second one, again, you are asked to find the sum of negative to the power of k minus 5, where k run from 4 to 7. Here the index is k and the lower limit is 4 and our upper limit is 7. So what we need to do that we need to plug the value of k starting from 4 to 7 into the expression negative to the power of k minus 5. So let's begin with negative 2 the power of 4 minus 5, okay, then plus is negative, okay, there's negative here, again negative 2 the power of 5 minus 5 plus negative 2 the power of 6 minus 5, and finally negative 2 the power of 7 minus 5. Let's simplify this expression. Okay, negative to the power of 4 is 16, 60 minus 5 is 11, plus negative to the power of 5 is negative 32, negative 32 minus 5 will be negative 37, this is negative 3, okay, plus negative to the power of 6 is 64, 64 minus 5 is 59, this is 59, plus negative to the power of 7 is negative 128. Negative 128 minus 5 will be negative 133. Negative 133. Okay, negative 133. The sum of these integers will be equal to negative 100. Okay, negative 100. So this is B. Example 4B. Let's go to the next one. Here I run from 1 up to 5, and the general term will be 3, which means that for any values of I, an is 3, which means that when I is equal to 1, it is 3. When I is equal to 2, it is again 3. When I is 3, again it is 3. When I is 4, again 3. And when I is 5, it is 3, which means that you are asked to find the sum of the first three, to find the sum of 5 terms of the general term 3, which is going to be 3 times 5, which is 15. So we finish example 4. Please go to your textbook and practice checkpoint 4. Okay, checkpoint 4. So by this we finish the lesson. Practice all the checkpoint and also practice the concept checking from your textbook.